Hey, welcome back to Yeyu Lab. If you're a developer for LLM applications, especially focusing on the real-time voice and video interactions, the Gemini Live API is a must try for you. Many of us have been exploring its multimodal capabilities of Live API with its high responsiveness, speed, and extensive session continuation, and tools usage features to build attractive apps from POC to go live projects. But for a quick development stage, building a server environment for deploying your app is always a necessary but annoying work. So Google AI Studio provides an excellent sandbox called Build, allowing developers to prototype in real time without backend overhead and easily share their work and source code. To create an app in Google AI Studio, the user can easily click the start from a template or just type your prompt to let the LLM to generate a code base. When you start from a template, you will see there is a template library for you to choose from instead of start from scratch. Unfortunately, even though there is a live template, the template is a text-based app, but you can see that the template is a text-based real-time chat app instead of a truly live and multimodal chat combining the continuous voice input output with dynamic image context. Here you can see it's only send the text and receive the text. Even they use the live connect function to perform the real-time application. So this is a missing piece in this showcase demos to help us start from a very basic bidirectional multimodal live app. So to fill up this gap, I made this app and tutorial to detail the creation and clone of a multimodal live chat. I called Gemini Live Voice Assistant directly within the studio, and my goal is to demonstrate how you can build applications where the users can engage in real-time voice conversation with the Gemini Live API, upload the image that is then periodically sent to the model, providing ongoing visual context to the chat, receive spoken audio response from Gemini that can consider both the voice and image inputs context. So this approach addresses the desire of a more contextual and interactive multimodal experience, all within the convenient browser-based environment of AI Studio. You can see since the coding language should be JavaScript, TypeScript in the Google AI Studio, this video can also be a guide for you to build a JS or TS-based application under a mainstream framework like React, calling the Gemini Live SDK directly by easily moving the source code to your own framework. Here, let me show you how it works in this application. Let's enlarge this app window. Upload the picture that we want to share. And press talk. Hey, what do you see on this page?
I see a person sitting on a beach, seemingly interacting with a large dog. Is there anything in particular you'd like me to focus on?
What type of this dog?
Based on the image, the dog appears to be a Labrador Retriever. What makes you curious about the dog's breed?
So what do you think of their feelings?
From the image, the woman seems to be enjoying a peaceful moment with her dog, perhaps feeling happy and connected. What feelings do you perceive in the image?
Yeah, I feel it's very calm. So what's the weather and what's the temperature do you think it is?
Judging from the clear sky and the way the sun is setting, it looks like a calm and pleasant day. It's hard to say the exact temperature, but I would guess it's mild enough for them to be comfortable on the beach. Does that align with your impression?
Now let's look at the block diagram and the data flow of this app. It's very simple that our application operates entirely client-side functionality and leveraging the browser's capability and the Gemini JavaScript SDK. So from the user import, the user interactive with the system via the voice and image uploads. The voice coming from the raw microphone audio is captured by the web audio API, and audio worklet processor handles the crucial tasks of resembling this audio to 6K Hz PCM, which is required by the Gemini model, and converting it to 16-bit linear PCM. This processed audio is then base 64 encoded audio from the main thread. About the image data flow, the uploaded image are read by the file reader API. Their base 64 encoded data and MIME type are stored locally for the later processing. And all this data are pushed to the Gemini SDK interaction, which both the base 64 encoded audio trunks and the base 64 image data sent periodically are transmitted to the Gemini API live session using the send real-time import method we will discuss in the code workflow over a persistent WebSocket connection established by the live connect function provided by the SDK. For the Gemini API and response, the Gemini model processes these multimodal imports, and the audio responses are sent back as base 64 encoded PCM back to the user, and as the output, the application decoded this incoming audio and played it back to the user via the web audio API. This client-centric architecture is ideal for AI Studio's sandbox environment, which is never relied on the backend and deployed services. Now let's quickly go through the code. Let's explore the key TypeScript code that orchestrates this multimodal interaction. Before that, after an empty template creation or other existing template creation for this project, we should make sure that we create those files to enable the full function and appearance of this project. So first, the index CSS, which is the style sheet of the application's appearance, and the index HTML is the main HTML page that is the entry point for the browser. You should make sure you import the Google Gen AI SDK from here that has the version 1.0.0 to align with the code in this project. And the index TSX, which is the main TypeScript file containing all the application logics, and the metadata.json is very important to define the name and description of this app. And one of the most important things is the request frame permissions, which is additional access request for this app to let the user click the microphone allowed to be used in this project. And then the tsconfig.json is the project metadata, scripts, and dependencies that's all included here. And the vite config ts, which is the basic vite configuration if you use vite framework as well. One thing is that you don't have to include your Gemini API key explicitly in the project source code, because the AI Studio will automatically link the user's own API key to the usage of this app internally. So don't worry, the full source code contained in these files have been shared along with the app through the AI Studio with the link that's showing in the description below, which are free to be used and viewed. Okay, so let's see the index TSX. Here are the definition of the package that's provided by Google Gen AI, and use the model Gemini 2.0 Flash Live 001, which support the Multimodal Live API. And recently they have provided another new Gemini 2.5 that supports native audio generation, which also can be used in this project. Then let's move to some key functionality and see how the code designed. Here there is an initialized audio system, which is for reliably processing the microphone audio in real time and ensure compatibility with AI Studio, where we load external script files for worklet as an inline text inside this code to generate a URL that can be added as a module into the audio context. So we don't have to provide additional backend processing code to be called. So inside of this audio worklet processor, it lives on a separate audio thread, ensure non-blocking audio processing. Its primary jobs are to take the high resolution audio from the microphone and downsample it to 16K Hertz, convert it to 16-bit PCM format, and then send these processed trunks back to our main application thread. And then let's see the connected to Gemini, which is very important to make this app keeping connected in WebSocket to the Gemini endpoint. So here the Gen AI Live Connect is the key function from the Gemini SDK to create a persistent bidirectional WebSocket connection. For its creation, along with the model and the config, which is a little bit familiar to us, there is a callback list that contains the key events of this connection, which are very important. Like on opening, tell us the WebSocket is on live. On message is where we listen to the server events. Here, the setup complete message is particularly important as it signals the session is fully initialized and ready for data exchange. We also parse the incoming audio responses in this message function and queue them for playback here. And also the on-error and on-close are vital for robustly handling the lifecycle of this connection. If you remember, the application allows users to upload an image, which is then periodically sent as context during an active voice session. So let's look at the image processing related code. When an image is uploaded, handle image upload function is called, process it into a base 64 string and store it locally. Start periodic image sending function, then triggered when voice recorder begins and the session is ready by detecting the is setup complete and is recording, and then set up the timer for it. The timer repeatedly calls the send periodic image data function, which transmits the current stored image to Gemini using the send real-time input, which is a very important function recently released, especially for the real-time style data, which you only send is the media data within the blob. This mechanism ensures that the latest uploaded image is always the one being sent as context. If a new image is uploaded, it will replace the existing image in the local storage, and then the timer automatically pick up on its next cycle. After the image part, let's look at the voice processing part. So here the start recording function ties together microphone access, the audio worklet, and the initiation of the periodic image sending. This function is the primary entry point for initiating voice interaction. It carefully manages the state, ensure that a connection to Gemini is established, and the session is also set up complete before attempting the access of microphone. Once this procedure has been done, it sets up web audio API pipeline. The microphone input is routed to our audio worklet node. The worklet processes the audio and sends the chunks back to the main thread, which then base64 encodes them and forwards them to Gemini via the same function send real-time input with the audio media blob data that constructed with the base64 audio data section and mine type audio PCM with the rate key value. Simultaneously, the start periodic image sending function is also be called to begin transmitting the current image context. Finally, when the user stops the interaction by click again the talk button, the stop recording is invoked to immediately set the record status as false and an image sending interval to clean up all the web audio API nodes, and importantly call this session close to gracefully terminate the WebSocket connection with the Gemini endpoint. That's all for this project. Again, the full source code can be found in the URLs that I shared in the description below. Make sure you have an account to access the Google AI Studio to use this app. In conclusion, this walkthrough demonstrates a robust approach to build a live multimodal application within the Google AI Studio by leveraging the audio processing and carefully managing the state of Gemini live session. We can create engaging experience that combine real-time voice with dynamic image context to perform voice and visual interaction in real time. And this AI Studio environment with its browser-based execution and easy sharing features make it an ideal platform for developing and iterating on such innovative AI application as a start. So I recommend it to go exploring the interesting apps here and create your own application. That's all for today. Thanks for watching, and I'll catch you in the next video.